Welcome guys to a quick little video, and in this video I'm going to show you how I made a radiation detector or Geiger counter using a Geiger Miller tube, that is the SI3BG Geiger Miller tube, which is rated for 400 volt of supply. And for that I have made a 400 volt supply using a mosquito killer bats transformer. And here's the circuit diagram. If I can show you the diagram, and there is the transformer that I have salvaged from one of the transformer, mosquito killer bat transformer, and in there the transistor was broken. It was, I suppose, D885, but I have replaced it with BD139, and there was a resistance of 470 ohms, and that is connected such way. And this is the high voltage line, and that is directly bridge rectified with bridge rectifier. And there you can see one of the bridge rectifier that you can salvage from any of the drivers, LED drivers. There you can see one of there you can see the bridge rectifier. It has also sign of AC input and DC output, so it is very convenient, and it is also rated for high enough voltage, 700 volt I think. And that output is then properly and there you can see a array of different diodes, Zener diodes. And in my case I didn't have any high voltage Zener diode, so what I have done is I have couple of 33 volt Zener diodes in hand. So I have coupled 11 of 33 volt Zener diodes in series with a 12 volt Zener diode, which comes to 407 volt of breakdown voltage across. So I have used that across the supply. There you can see the supply. And after that, for smoothing I have used polypropylene capacitor, metal polypropylene. It's a 440 volt rated capacitor. The marking is T224. And for smoothing that, after turning on the supply, I get 407 volt across the supply. Then I have seriesed couple of 1 mega ohm resistance to form around 5 mega ohm, because the Geiger tube very sensitive to current. You don't want to damage this, because this is the most expensive part of the whole entire project. The Geiger tube that I have ordered actually from ETSY website, ST whatever you wanna call, but it came from Ukraine. So from Ukraine, I don't know how, but it came from Ukraine. They still ship. So after that, we have used a detector butt. Detector butt consists of this 100 ohm resistance across. There is a capacitor, and there is two transistors. One of the transistors is NPN and one of the transistors is PNP, which is the 558 is PNP and this is the NPN. And there is a pair of them, and with a speaker and a LED, and through some passive components we can detect the pulse. So that I have made the detector circuit like this and directly soldered it. I want to enclose everything in a small little box, but I still unable to find one. So right now this playing bare, and I will show you the supply voltage and everything. And the whole project supply part, actually I have supplied it with 2.7 or 2.8 volt. I don't know how I am going to supply this, because the transformer winding inside the mosquito killer bat is quite high. The ratio is quite high. So at the output, in a 3 volt supply I can easily get 750 volt across this line. I don't know how, because the ratio is quite high. And across some so it will take quite a lot of current if I have to supply that. So I have somehow managed to use a 1.5 volt battery across this, so that this part can be powered. I have seen that this part will powered up, and it will supply 400 volt across. But you can see. So I'm going to turn on the supply, and I'm going to show you a couple of voltages so that you can take reference of. And you have this Geiger tube that is quite less sensitive. In order to have quite a lot of sensitivity, you have to order quite expensive Geiger tubes, which were SBM 20 or something, because this the detector part is quite small in this case, so it will be much less sensitivity. And for detection, I have some gas mentals, which is consist of thorium isotopes. So this is radioactive, but not much. I don't think you can get much of sensitivity out of this tube, but couple of ticks you can then determine whether the source is radioactive or not, because the lot less sensitivity, you need quite higher strong source to actually trigger the whole system. But you can get few clicks out of it. I can say 3 to 7 pulse per minute, I think. So let me show you the voltages. So there you can see I have connected the supply across the system, and the supply is drawing 0.06 ampere, that is 50 milliampere, and supply voltage is 2.5 volt. And if I can show you what is the voltage across the supply actually looks like. So you can see, as I said, 4.6 or 7 volt, it toggles between 4.6 and 7. So the supply part is actually working, and if you measure the voltage across the supply line, you can see making noise because the internal resistance of the multimeter is around 10 mega ohm. So with 5 mega ohm in series, it will show you wrong value. It will show you half of the supplied value that you can see, but actually this false, because the high impedance loading by the internal resistance of the multimeter, you get the wrong voltage. But in the supply side, you can see we have 406 volt, and the detector part consists of one LED and the speaker. And when any high energy pulse actually passes through the detector, it will show me, and it will make noise on the speaker. So right now I only have the source like this, and for this to make a quite reasonable pulse is quite low, because I need much hotter source, which I don't have right now at this moment. But if I can get some X-ray or some other things, I might be able to get some clicks out of this. But I will try to order some more sensitive probes, because they will perform much better. They will at least 10 I think 10 clicks per minute, 10 counts per minute. So there you can see nothing much, but it will give occasional pulse if we get much closer. I don't know if you can hear very faint but occasional. It might take 1 or 2 minutes to get even 1 or 2 clicks. So I don't think my radioactive source is quite reasonably hot, but it works, because if I short circuit the supply with some wire, I think I can get you to click. And the basic method of getting clicks out of the, there you can see, you can hear clicking. If I short this across, you get some clicks. So that shows that the system actually working, but the occasional click of the system so less. I at this moment I can't show you, but this system actually works. And this is a quite cheap Geiger Miller tube that you can order. It cost me in Indian rupees around 900 rupees to ship into my location. from Ukraine, and so yeah, this is the radiation detection thing. And if you connect some capacitor across the speaker and get some cheap audio ADC and connect with your computer and use couple of detection counter applications, couple of videos I have on my channel. So in if I use that application and take the counts per minute, I can surely see some result, which I will do in next video in future. So that's it for this video. I hope you guys liked it. So I will see you guys in the next video.